good evening, everyone. Okay, thanks again for joining me today for another class technique and Java. So today I'm doing it on a Sunday because I was not free yesterday. All right. Okay. So it's usually going to be a Saturday except for this week lah. All right. Okay. So today I've chosen another question which I find is quite challenging lah. Soal yang mencabar. Okay. So usually the questions that students that I find very difficult are usually the ones that are related to genetic engineering, then all these variation and genetics. So today my topic here is also on genetics. All right, so this is actually an SPM level question. Okay, so the questions that I'm choosing actually are all these SPM level questions. That means it's very the format of these questions are similar to these actual questions that come out in SPM. All right, okay. So today I'm sharing this slide. I hope you can see this. Right. If you would like to tell me who you are or whether you can hear me, am I making, is it loud and clear to you? Can you please, maybe you can comment here so that you can hear me. Okay, if you can, then just let me know. All right, if I've no comments here, I'll straight away go to the lesson. All right, okay. So this today, Technique Menjawab Biology, this is the third lesson in my series lah, okay, in preparation for your SPM lah, because SPM is coming soon, very soon, okay, so in less than about 1 month. All right, so I'm going through every week discussing with you difficult questions, usually the essay questions. Okay, so I'm going to choose one essay question every lesson to discuss with you what are the answers, the answer scheme, the answers that you should write in order to get maximum marks or full marks. All right, okay, so let me start now. All right, so here, for those people who do not know who I am, so I've been actually having my YouTube channel since the pandemic started. That was in 2020. All right, so I've been making classes under this Academy YouTuber. So this is a private channel. So it's also under Academy YouTuber, but the time is not in their session lah. So I'm choosing another slot. Okay, so this is my private class for everyone. Okay, no payments are involved. All right, everyone's free to join. So I'm from Ipoh, right, and I've been teaching for biology for in my teaching career for 31 years. All right, 31 years, and my option is biology and English. Okay, all right, so that's all about me. So let's go straight to today's question, which is a challenging question. Most students tell me that they do not know how to start and how to answer it to get marks. First of all, you need to remember your facts must be there. Okay, you need to know your facts. If you're not sure, you can go check out my many lessons that I've already done in Form 4. I've already covered from chapter 3 to chapter 15. Chapter 3 to chapter 15, which is all the chapters are done. All right, you can go through. And Form 5, I've got certain chapters. So next year, I will continue with doing more videos of Form 5. All right, okay, let's start with this essay question. 20 marks, yeah? So it's either bahagian B or bahagian C. Section B or section C for your paper 2. So I have a choice. Question 9 or question 10, you can choose one, and question 11 is compulsory. Okay, so now diagram 1.1 shows the inheritance of this variation called type of earlobe in a family. Okay, type of earlobe. Okay, I will have the same lesson in BM another time. All right, so today I will explain in English, but you will see that my slides are in dual language. You will see the answers in BM as well. Okay, right. So this is the question. Father has this kind of earlobe, mother similar, then the son has got slightly different, all right, and daughter here is same like the father and mother. So these two type of earlobes, yeah, one is called free, father and mother is free, and the daughter is also free. The other one is attached earlobe. Okay, the son has attached earlobes. So here the question here is explain the type of variation. Okay, type of variation. Type. There are only two types of variation actually. All right, there are only two types of variation based on the characteristics that are shown in the diagram. So your answer is either just the name. All right, does anybody want to answer this? Is there anyone who knows? I think it's a very simple question. All right, you can answer me the type of this, the type of variation. Don't give me earlobe. All right, What I want is the type of variation. Don't give me it's attached earlobe or free earlobe. I want the type. All right. Okay. If you don't have nobody's there to answer, so I'll carry on with the question. Yeah, I'll give the answer. So either it is uh, continuous or discontinuous. So the answer that they want, this type is discontinuous. Okay, so 2 marks. This one is just one section of the question, which is A1, only 2 marks. So they always start with the easy questions first. Then slowly they progress to more and more difficult questions. Okay, so the answer here is, because it's 2 marks, all right, the first one you have to mention the name. So it's discontinuous variation. This continuous variation is very easy to see. Either you have particular groups, either it's this group or the other group. Okay, there's nothing continuous. Okay, it's not something that is joined, continuous. It is either this or that group. It is totally different. This type and the other type, I mean this type of earlobe and the other type is totally different. You can see the differences. So what do you do with the other mark? You have already mentioned the name, which is discontinuous variation. Remember, a lot of students just mention discontinuous variation and that's it. Okay, you will lose 1 mark because this question has 2 marks. You have to say something else about the discontinuous variation. Okay, so you mentioned something else. Anything related to the characteristics of this type of variation. Okay, so you say that this characteristic is clearly defined. That's very obvious. Either you are this type or of earlobe or you're the other type. Okay, there's nothing that in between. There's nothing in between. Either you are attached or you are free earlobe. Okay, so other characteristics that you can say is this characteristic is qualitative. That means it cannot be measured. It's either this or that. You cannot measure. It's not length. It's not the length of your fingers, not the length or the height of the body or the weight of the body, right? You cannot measure. There's no number there. Okay, next one. This is determined by genetic factor. That means you're born with it. Either you have attached earlobe or you're free earlobe, you're born with it, right? It's also controlled by a single gene, all right, and it's not affected by environmental factor. There's nothing you can do that will change this. Nothing you eat, nothing that you can affect it. You're born with it. That's it, right? It's because of genes. So that's the third one, right? You can also say it is this type of variation is represented by a graph that shows discrete distribution. That means usually it's represented by bar chart. Okay, this group, how many individuals? The other group will have how many individuals? So it's bar chart, not a line graph. You don't draw line graph for discontinuous variation. You draw line graph only if it's continuous variation, like height, okay, or mass or body weight, right? Okay, so this one is not, there's no intermediate characteristics, all right, because either this group or that group. Okay, so any how do you get 2 marks? 1F, which is the name of the type, plus any one of the P's. Okay, F plus any P, any of the points here. Okay, there you get 2 marks. Okay, which is 2 marks, right? Usually the first question is very easy. Okay, let's go on to the next one. All right. The next one is, of course, it goes slightly a little bit more difficult, right? Now, diagram 1.2 shows 2 chromosomal arrangements at the equatorial plane during meiosis. Okay, you notice that during meiosis, the time when the cell divides, the chromosomes will line up in the middle. Okay, and there are 2 ways. Either you will see the arrangement number 1 on the left hand side. All right, you'll see the black on the left hand side, the big black and the small black, and then the white one, the big white and the small white on the right hand side, right? It can be like that, or it can be arrangement 2 whereby the black and the white, big black, small white on the left hand side, or the big white one and then the black small one on the left hand side. You see, this arrangement is actually free, random arrangement. How they are arranged is up to the chromosome. It is like a game of chance. It can be, doesn't mean that all your black must go on. If the black is from the, let's say, the paternal from the father's side, right, the chromosome. Then the white one is from the mother's side, let's say, maternal chromosome. It doesn't mean that black must be on the same side. It doesn't mean the white must be on the same side. All right. So there are two ways of arrangement. Okay. Now what's the question? So let's see what happens if you have these two type arrangement. That therefore, if you follow through uh, you call the segregation of these chromosomes and so on, you see at the end you have more than two combinations that are possible for the gamete. Okay, you see the one over here, black, black. Then this one, white, white. All right, gamete, possible gametes that can be formed. Then over here, you got black and white. All right, the big one is black, the small one is white. And then another one over here, you have the big one that is white, the small one that is black. So actually, there are four types of combination that are possible. Okay, right. So what's the question? The question here is, all right. Now once I switch the slide, it takes some time. Okay, now describe the chromosomal behavior. See what it means by chromosomal behavior. You need to talk about the chromosome, where, how is it situated, how we will move, and so on. Don't talk about spindle fiber. Don't talk about the nuclear membrane disappear and all that. That is not chromosomal behavior. Okay, chromosomal behavior is they want you to describe what happens to the chromosome. Okay, they are arranged where, and then when they separate, what separates? Is it a homologous chromosome separate, or is it the sister chromatic separate? Okay, they want that. So P phase and Q phase here. So there are two phases here, right? Here is during the meiosis 1, right? And then phase 2 is during meiosis 2. Okay, so at the end of meiosis, you will find you will have gametes. Actually, the daughter cell are actually gametes. You have 4 different types of gametes that are possible to reproduce. Okay, so explain the chromosomal behavior. During phase P, which is this one, right? And also Q, right? So you have to mention 2 things. Okay, 5 marks here. Okay, let's see the scheme. All right. Right. So during P, right, you can, because the name is not given. If the name is not given, you can state the name of the phase. So phase P is metaphase 1. Okay, now what if you say it's meiosis 1? Okay, now meiosis 1 is too general. It's too general, it may not be accepted. So be specific. It's better for you to be specific when you answer questions. Okay, because sometimes the marks are given for certain situations that require you to be specific. Usually, we want you to be specific. All right. So if you say meiosis 1, the answer may not be accepted. Okay. All right. So phase P is metaphase 1. You know that because it lines up in the middle and it's 2 by 2, right? That means it is the homologous chromosome that line up there in the middle, right? Now, pairs of homologous chromosomes are arranged at the equatorial plane randomly or independently. Okay, so what you need to explain is what is happening at this time during metaphase 1 is pairs of homologous chromosomes. So I stress this word, homologous chromosome, because what is arranging at that moment is actually the homologous chromosome. All right, because they are paired, the big and the big chromosome, the small and the small. Okay, so it has to be pairs that are arranged at the equatorial plane. Okay, so be careful with the term. If you do not mention homologous chromosome, you will not get your P2. You cannot say pairs of chromosomes are arranged randomly or independently. You do not get your P2. You must have the word homologous chromosome. Okay, all right. Then what happens then at Q? Q is the other one. The other one's after meiosis 1, you will have the meiosis 2, right? And then it will line up again, but this time it's not the homologous chromosome because they are already separated. Now it's just that chromosome, right? Then you will have, it will split right down the middle. The sister chromatic will separate. So this is metaphase 2. Okay, again, if you are too general by saying phase Q is not meiosis 2 because phase is specific to that phase. Meiosis, there are 4 phases there, whether it's prophase, anaphase, metaphase, or telophase. So that's why we do not accept meiosis, either meiosis 1 or meiosis 2, because it's not the phase. All right, meiosis is the process. Meiosis is the entire process. But what they want the phase is either they want the prophase, metaphase, anaphase, or telophase. Okay. Now, what is happening at metaphase 2? Notice that metaphase 2, they line up again, but now is the sister chromatids are arranged. Okay, there's no longer homologous chromosome because they already split into the other cell. All right, so at this time now, it is more specific. You have to say the sister chromatids, or you can say chromosomes, because that one X shape that you see here is one chromosome. They are arranged. Again, this is randomly, freely, yeah, because how they are arranged, what chromosome pairs, what chromosome actually is all a matter of chance. Okay, that's why we call the random assortment during meiosis. When how they split, how the chromosomes end up in the left hand side or the right hand side of the cell is actually random. Okay, all right, so you must mention they are arranged. What is arranged at where, right? Randomly and freely. So therefore, because they are randomly arranged, they will produce gametes with different combinations. So that's why you see the black, big black, small white, and then you have the big white, small black. You see there are 4 different types of gamete that you can get. So it's more than one chance, or more than one type of gamete you can produce. Okay, so here this is you have to mention what is happening here. You have the random or independent assortment of chromosomes. Okay, because you have 2 ways. If you have 4 chromosomes, you have 2 ways you can arrange. If you have 46 chromosomes, you will have many combinations that are possible, up to 8 million combinations if it is human cells or human chromosomes, because you have 46 chromosomes. All right, there's a formula to count that. All right, I do not want to confuse you. There'll be 8 million combination that's possible. For here, because it's only 4 chromosomes, right, you will have definitely more than 2 types. You have 4 chromosomes. All right, okay. So here, these are the points that you can answer. All right, so you can write any 5 points here in order to get your 5 points. Any 5 full marks here. All right, okay. All right, let's go to the next question. Yeah. Okay, so this is only a small part of the question. That was the A2, I think. Yeah, now let's go to B. Yeah. So B shows 2 persons, 2 individuals with genetic disease. Okay, you should be able to recognize if I show you the karyotype. Karyotype is like a picture of the chromosomes nicely arranged by the pairs, chromosome, homologous chromosome pair number 1, 2, 3, 4, until pair number 23, which is the sex chromosomes. You should be able to recognize what problem they have. Okay, what genetic problem they have. If you cannot remember, if you cannot recognize, that means you need to revise this. Okay, so I've highlighted, circled the problem there. You will see carefully. Very obviously, 21 has got 3 copies of the chromosome. And for this one, individual B here, 1.3B, this is one part of the segment of the chromosome is missing. And this happens to be chromosome number 5. All right, okay, chromosome number 5, not any other, is chromosome number 5. One segment happens to be missing. Okay, what is the question? The question here is compare. All right, so compare and contrast these 2 genetic diseases, 5 marks. Okay, now always be careful. I will see out of 10 students or 10 candidates, 9 will always go straight by saying the differences. They will forget to mention the similarities. Okay, in order for you to get full marks, you must have similarities and differences together. You cannot be mentioning only one thing. Okay, so you look carefully. This is 21, got 3 copies here, and the number of chromosomes here will be 47. Okay, if you count right? You need to count then you should know. Then over here, you will have 46 chromosomes, right? In terms of the number, is normal, but you see that the structurally, it's not normal. The number is normal, but the structure is not normal, right? Because it's missing one segment of chromosome number 5. Okay, so similarity first. All right, similarity, you just write in terms both, what blah 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 blah, right? So what happens? Both are actually chromosomal mutation. There are examples of chromosomal mutation. Because when you say chromosomal mutation, either the number is wrong, under the number is abnormal, or the structure is abnormal. So you can see, for example, the one on the left-hand side, the number is abnormal, and the one on the right-hand side, the structure is abnormal. So this is chromosomal mutation. Okay? If it's the other type of mutation, which is gene mutation, you will not be able to detect it under the microscope. You cannot see it because it looks exactly the same because it's at the gene. The abnormality happens at the gene, and you cannot see it physically from the chromosome. You can't see right down to the gene level. Okay, you cannot see the segment, the what they call the sequence of the genes. So it looks normal in terms of the number, the sequence. For gene mutation is not traceable under the microscope. But over here, chromosomal mutation, you can see either the structure is missing, right? Some part is broken off, or the other one is the number is not normal. Okay, so therefore, this is chromosomal mutation. Okay, now both are caused by mutation. Okay, so we do not know what mutation. Maybe the person or maybe individual, the mother, the father, right, has been exposed to gamma radiation or X-ray, excessive X-ray dosage of the radiation, whatever lah, that causes the formation of the gamete to be abnormal. And then therefore, when you have the fertilization, a sperm that is normal, maybe fertilize an ovum that is abnormal, then the number will be abnormal. Okay, 23 plus 23 plus 24, you get 47. Okay, next, both occurs during gamete formation. Yes, the problem comes is because of gamete formation. Maybe the sperm has a normal number of chromosome 23, but the ovum is the one that is 40, abnormal, having 24 chromosomes. Then when fertilization occurs, you will have 47, and there you have the Down syndrome. Okay, they both involve autosomes. Yeah, okay, the problem lies in the autosome, not with the X and Y chromosome, not the sex chromosomes. You will see that for the syndrome, Down syndrome is the 21. Okay, we circle there are 3 copies there. And then for the other disease, which is on the right hand side, later you see the name, you find that the autosome, the chromosome number 5 is autosome, yeah? That one is broken off. Okay, so it only involves autosome, nothing to do with the X and the Y. So it's not Down syndrome, it's not a Turner syndrome, it is not Klinefelter, nor either it is the, what you call the other one, Jacob syndrome. Okay, that one is XY problem, right? The sex chromosome problem. Okay, then both individuals here are mentally retarded or state any correct characteristics that refer to both. Okay, both also have. Okay, so it depends. This is like we do accept any other answer that is logical. It doesn't have to be exactly the same. Okay, so any one, in fact, it's safer to always give 2. Okay, give at least 2 similarities and the rest of it, leave it for your differences. All right, now differences. Differences you can write in table form. No harm in that, no problem with that. The only thing is, do not just write one word. Please write a sentence and make sure it is a phrase, at least a phrase, not just one word. Has, don't have, or don't have what. Okay, you cannot just say that. So you have to write in sentence or at least a phrase. And then if you were to write in paragraph, that will be very wrong. Don't write in 10.3a, everything about it in one paragraph, and then 10.3b in another paragraph, because you're not comparing. You have to write sentence by sentence. Okay, so you mention like this: diagram 10.3a shows blah 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 blah, but diagram 10.3b shows blah 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 blah. Okay, you define the difference in one sentence. Compare both things in one sentence. Okay, so let's say the first one is, the name is not given, right? So you can give the name. So having 3 copies of chromosome number 21, this is Down syndrome. Down syndrome, okay? And then the other one, right? The one where has got one segment of the chromosome number 5 that is missing. It got broken off and it disappeared, right? So this one is, you look at a textbook from 5, you do have this. Don't say you haven't learned before. I'm sure a teacher has taught you before. This is Cry-Duchet syndrome. It's a French name, a French word, right? Chat in French means cat. So cry du chat is cry of the cat. So this child who has syndrome cry du chat will cry like when the baby cries, it sounds like cat meowing. Okay, this is very weird, right? So this is what happens when you have cry du chat syndrome, which is characterized by a missing uh, segment of chromosome number 5. Okay, now due to what causes it to happen? Your Down syndrome is due to non-disjunction. Okay, now remember this word non-disjunction means the chromosomes when they line up either during metaphase 1, all right, meiosis 1, metaphase 1, they line up, the two homologous chromosomes together like this, right? Look at my finger. Look at my finger. Like that, right? Okay. So what happens is they non-disjunction means because of the failure of formation of spindle fiber on both sides, all right? So if both of them, one side don't have, let's say one side, so this one they grow to this side. Both the chromosomes are pulled to one end of the pole of the cell, meaning the other chromosome should go to here, it did not go. All right, so that's why the number of chromosomes is not normal when you have non-disjunction. So it can happen during meiosis 1, metaphase 1, or anaphase 1, or it can happen during anaphase 2. Also can, where the sister chromatic fail to separate. Okay, so that is non-disjunction for Down syndrome. But for cry du chat, it is not due to non-disjunction because the number is correct. Okay, the person has got 46 chromosomes. The problem is that segment of chromosome just went missing, hilang, right? So this is due to deletion of chromosome segment. In fact, chromosome number 5 lah. Don't know what happened lah. It's actually maybe due to radiation, due to mutation. So that part of the chromosome just disappeared, right? Okay, so remember to compare the same feature. Okay, next, what else can you talk about? So talk about the number, right? Down syndrome is characterized, whether you can say this individual has an extra chromosome, which is number 21. Not any other. You have to mention 21. Okay, you cannot just mention extra one chromosome. You must mention is 21. And for cry du chat syndrome, the problem is like chromosome number 5. It is missing the segment. Structural changes of chromosome number 5. Okay, so you mentioned the number, chromosome number. All right, okay, next. 10.3, D4, difference number 4. All right, you talk about the total number. For Down syndrome, you have 47. The total number of chromosomes increased by 1. Okay, whereas for the other one, which is cry du chat, it is same. Number is normal. It's just a segment hilang only. Okay, so you're comparing here. D4 is comparing the number of chromosomes. Okay, lastly, D5, we can talk about any feature. Any feature for this Down syndrome and also this cry du chat. All right. So for Down syndrome is all these basic, we call it very general and very characteristic of the feature of a Down syndrome person, which has got slanted eyes, flat nose, right, and protruding tongue. So the tongue is a little bit bigger. That's why you can see they normally can't close their mouth properly. So that's why the tongue is like protruding, all right, and then it looks a bit weird lah, right? They have a very, very particular kind of a look on their face. And for here, cry du chat is characterized by the individual or the baby cries, like the cry of the baby is similar to cat meowing. Okay, and they also have mental retardation, speech problem, and so on. Okay, any correct characteristics. As long as it is correct, that means if you textbook mention that, definitely correct, right? We Google it, we also accept. All right, so make sure that the characteristic is correct, right? Don't reka your own, don't invent your own, because these are all facts. So at least one similarity and the rest can be differences. So that would be a total marks, all right, which is how many? This one forgotten. Sorry, it's 8, right? 8, 8 or 5? I think 5. Sorry. 5 marks. Okay, so 5 marks. So usually it's 1 plus 4, right? Okay, let me go faster. Right, so to flash you again this. Later you want to copy this down, you can just pick the link again. You can just uh, pause it, then you can copy it down. All right, okay. Next question. C question, the most difficult one, right? The last part is always the difficult one. So it incorporates this question on chapter 13, form 5, right? So diagram 1.4 shows a genetic engineering technique. Genetic engineering, it is to actually genetic engineering is manipulation of the genes. We manipulate the genes to produce, to make this organism do something that we want it to do. Okay, for example, we want this bacteria to be able to produce insulin, to make insulin so that humans can use it, for the diabetic patients. We sell insulin to these diabetic patients all over the world because humans can't make it fast enough because we need it for ourselves. We can't have so many, pancreatic cells to produce some more insulin. So we are making the bacteria help us to make the insulin. So first of all, we need to put in the gene for making insulin into the bacteria. Okay, so now the bacteria has become genetically modified organism. That means this bacteria is no longer normal, no longer original one. We have genetically changed it. Modified means changed. Okay, now that is insulin. Now this is a application for making this uh, bacteria which is able to produce an enzyme called benzyl succinate synthase. Okay, don't worry about all these things. You don't need to know the facts. You just need to know the principle behind it, which you actually have already learned in chapter 13, genetic engineering. Okay, later I show you the picture. Right. So we are making this bacteria able to treat oil spill. Okay, you have tumpahan minyak on the surface of the sea. You have this oil spill. So you want this bacteria to produce substance to break down the oil. Okay, break down the oil so that it's easily, it will not harm the aquatic organisms and all that. Right? Okay, now look at the picture here. So you will see that diagram 1.4, you'll see this Pseudomonas species, right? You actually modifying it. When it's modified, this bacteria is now no longer normal. We call it transgenic. Okay, this bacteria is called Pseudomonas, but this is the original one on top here. All right, this is the original one. But you see, we have added in what? The gene to synthesize, to make this enzyme. This enzyme is going to break down the oil. So we insert this gene. The gene is the ability to produce this enzyme. We put it inside this bacteria. Okay, and once it's inside, now the bacteria, we let it multiply. Okay, we make millions of it so that we can produce more of this enzyme. Okay, so this is one application of genetic engineering, is to help us to make certain substances or product which can solve problems. And here in this case is environmental issues. Okay, to solve the oil spill. All right, okay, let's continue and see the answer. Oh wait, where's the question first? Question first, So normally they want you to explain the process, right? Describe, okay, the engineering technique in producing transgenic Pseudomonas to treat oil spills on the surface of the sea or ocean. All right, so 8 marks. So 8 marks here, that means you need to be step by step now. What you need to do. In fact, in this picture, they already show you a little bit, but they don't give you too much because they want you to write it yourself. All right. If you copy anything from here, actually, if you copy word for word, right, the actual process is already mentioned here. If you mention again in your answer, it's no marks, right? Because you are not giving any input from yourself. If you're copying it, what is already given, you won't get any marks. All right. But you can see here, multiplication is not written, isn't it? You see the this bacteria. Once you modify the bacteria, you clone it. You make copies of it. That one you can write and you will get marks because it's not mentioned here. Right? No words to say bacteria is cloned. Okay? Bacteria reproduces. No. So whatever is not written, please write. Whatever is written, don't repeat. Okay? Now, 8 marks. Where do you get 8 marks? Okay. Okay, first of all, you need to mention The plasmid, okay, the plasmid is the circular DNA. Circular DNA that is found in bacteria. Okay, so only in bacteria you will have this circular DNA. All right, so you take out, it is remove and cut. Okay, now cut not using scissors, right? Cut using restriction enzymes. Always when you talk about this genetic engineering, you need to cut that segment there and you put in another, the gene that you want. You always cut using restriction enzyme, okay, or enzyme pembatasan. All right, so the gene, and then at the same time, you got to take the gene that you want. And this is from denitrifying bacteria. In the picture already shown you. Okay, this bacteria contains the gene that you want. Now you want to take this segment of the gene and put it into your pseudomonas. You want your pseudomonas to have the ability of this bacteria, the denitrifying bacteria, to break down the oil. Okay, so the gene is cut. So how to cut the gene? Using restriction enzyme. Okay, by saying that term, saying the word that you will get your mark also. All right, so you need to take out, first of all, take out the plasmid from the bacteria, pseudomonas. At the same time, you take out the gene that contains the DNA, all right, for breaking down the oil, all right, breaking down the oil in your whatever lah. Okay, you take it out, and then now you take it out using what? Remove using restriction enzyme. Then you got to combine it. Put this inside. Put this DNA of this denitrifying bacteria into the pseudomonas. Okay, so the gene. Okay, gene is cut, not DNA. DNA is too long. You need the gene on it. Gene is one segment of the DNA. So you got to identify which segment will contain the gene to make this enzyme. Okay, so it's cut. Then you insert into the plasmid. Okay, not insert DNA. DNA is too long. You know, millions of, the base pairs and all that. That is DNA too long. You need the gene on it, that specific segment of gene. So gene is important, not insert DNA. DNA is too many genes there. Okay, then by using how you join it together, just now you cut, you use restriction enzyme. Now you want to join it back, you use DNA ligase enzyme. Okay, I'll just say ligase enzyme is to join it. All right, okay. Now once you join it, now your hasil, your product here is no longer normal, no longer the original combination of genes, right? It's no longer the original. So we call it the recombinant plasmid. So this circular DNA now does not have the original composition or no, the components of the gene. Now it's already modified. We call it a recombinant plasmid, okay, or recombinant DNA. All right. Now, what do you do with this? What do you do with this? You put it back into the pseudomonas, because just now you took it out. You took it out to modify it. Now you put it back into the pseudomonas. Okay, now the recombinant plasmid or the recombinant DNA is now inserted back into the pseudomonas. Okay, don't ask how it's done now. You don't need to know the details how it's done. The principle only you need to describe. Okay, if you want to know how it's done, go to university level where you major in genetic engineering. Then you will know how it's done. Okay, even for me, I do not know the details. What we need to know is the principle, how to do it. All right. Now your pseudomonas is no longer the original, right? We call it transgenic pseudomonas. They already modified. You already changed the composition of the genes. Now this pseudomonas has the ability to produce the BSS enzyme. Okay, the BSS enzyme that will break down the oil. So now what you're going to do with this is only, let's say, one bacteria. One bacteria too little. You cannot produce enough enzyme for it, right? So you need to multiply it. Okay, bacteria, the good thing about bacteria is, what is so good about bacteria? Why are we using bacteria all the time? It's because bacteria have a very amazing ability to reproduce in a very short time. In 20 minutes, your bacteria will multiply. From 1, you get 2. Okay, don't say 2 too little, because you give it another round, 2 becomes 4, no. 4 becomes 8, 8 becomes 16. It's always times 2 because 1 binary fission, right? 1 becomes 2, 2 becomes 4. So the number actually multiplies very quickly. For bacteria, they actually can multiply you call it asexual reproduction very quickly. Okay, so there's clone. You make more copies of it. Okay, or you call it multiply, or you call it bread. Bread means dibiarkan, right? When you give these nutrients and all that, let it grow in other words. Okay, then you have thousands, already millions of it, let's say. Now what do you do with it? Now you take this transgenic Pseudomonas and you bring it to the sea. You sebarkan, you spread it to the sea. Now this Pseudomonas has the ability to produce the BSS enzyme. It will break down the oil. That's what you want. Okay, this is what you want the bacteria to do. Right? But before you want it to do, you've got to put in the gene to be able to produce the BSS enzyme. All right, okay, so what it does is it's going to degrade the oil or break down the hydrocarbon, all right, and then of course you'll be less harm to the aquatic organisms and so on, right? So this process of breaking down this oil, this bacteria will be able to produce energy. Okay, so this energy will be used by the bacteria actually. So it is what you call this chemotrophic uh, nutrition, chemotrophic. All right, so any 8 points from here. So usually all these questions are, the difficult ones are, students can't really do well because they find this concept difficult to understand. Difficult to understand, all right? They cannot, sometimes students they cannot see the thing, they cannot understand, all right? But you have to understand the concept, all right? So always refer to your textbook. Now, refer to your Form 5 textbook, page 283 and 288, all right? I'm going to show you now. If you can have your textbook, later you're going to have a look at it. So this is the one on the left hand side. This is the picture taken from your textbook about production of insulin using bacteria. Of course, you don't use Pseudomonas, you use a different kind of bacteria, which is usually, I think, E. coli, right? Again, the same principle. You take out the plasmid, see the plasmid, right? Then you take out the insulin gene, which is from the pancreas, human pancreas. Then you see you cut away this one using restriction enzyme, the same concept. Then this one you take away also, you cut away using restriction enzyme, and then you combine it with DNA like this. You see, everything that I mentioned just now is from the textbook. So treat your textbook like your Bible, your biology Bible. Everything is there. If you pay attention to it, you read word for word, you remember everything, I can guarantee you, you will do quite well. Okay? You may not be able to score because scoring needs more knowledge, right? But if you can pluck out everything from the textbook here, you will do quite well actually. All right. So you see, after that, you get this recombinant plasmid. All right, this I mentioned just now. And now you insert it back into the bacteria. All right, the bacteria is usually one of the bacteria that doesn't cause diseases, right? Then introduce back the bacteria. Now you see this plasmid goes inside, right? Plasmid goes inside. And what do you do with it? You clone it. Bacteria clone, right? You clone it and then it multiplies. And we got thousands and millions of it now. This bacteria is able to produce insulin. Okay, so the insulin is extracted, taken out, right? And you purify it, you put into bottles, the small little bottles to be injected by the patient or by the doctor. Okay, so this one is application of genetic engineering to produce bacteria that can produce insulin. Actually, it's the same process. Just now, the one we discussed about Pseudomonas producing the BSS enzyme. Produce what is not important, but the principle is the same. Okay, so here, cleaning of oil spills, right, is bioremediation using organisms. Bio means life, using plant or using animals, here using bacteria, right, using living thing to clean up environmental pollutants. So you see, we just we mentioned just now about degrading the oil by bacteria. So you got to apply this first. You got to apply this technique of putting this gene to break down the oil into the bacteria. Okay, now example of bacteria that it's can be used, Alkanivorax bocumensis. All right, it's a type of bacteria that uses oil as its source of energy. That means it carries out chemotrophic nutrition. Okay, it will treat oil spill. It breaks down the oil. All right, okay. So I can give you one advice, all right. For essays, from 5 SPM, right? Please do not forget important concepts in chapter 11, 12, and 13. Because definitely there'll be something on genetics, especially on environmental issues like this, breakdown of oil and that, all that, or making, genetic engineering, producing BT corn and all that, there will be usually a question on it. Genetic engineering, environmental issues, energy, all right, green technology, usually it will be found in questions, the essay questions. And also things like eutrophication, BOD, all right, biochemical oxygen demand, pollution. All that will be in uh, question either 9, 10, or 11. Okay, so I repeat, genetic engineering, variation, all right, variation, genetic engineering, environmental issues, okay, and also dynamic ecosystem, all these, energy, green technology, and all that. So that is important. All right, please do not forget that. Always revise, do questions, as many as you can. All right, okay. So that's all for today. All right. So today I don't have anyone commenting. So you can always watch this again to copy down the answer scheme or to share it with your friends. All right. So I hope that I'll be or next week or the week after I will have another class to discuss more challenging questions. So this is third in the series. I hope to carry on until your bio paper. All right, the bio exam paper. All right, okay. So thank you very much for watching. And by the way, I just want to tell you that I have a, you can telegram me, if you would like to, okay, p.me, if you would like to ask me questions, I am most willing to help you answer questions. In fact, it helps me also. I learn more things, right? So I'm going to give you my telegram name. You can just message me. And my YouTube channel is here, www.youtube.com. Just go through and see any concept that you do not remember, you do not learn well, all right? Maybe teacher taught you, but you were absent or whatever, a bit blah blah. Go through that classes, right? Or on the videos and all that. All right, after Form 4 and Form 5. Form 4 is mostly almost complete except for chapter 1 and 2 only. All right, okay. So I hope to see you next week then. All right, okay. Bye-bye. Have a good weekend. All right, okay. So wait, let me start the... all right, okay. See you. Bye-bye.